All right, we're going to be talking now about how to solve some systems of equations. And with this one, we're going to show you how to solve by substitution. And the thing with substitution is we can easily solve an equation with a single variable. But when I've got two, we need to get rid of them one way. Well, one way to do that is to substitute out that variable for some expression of the other. So let's go over what we can do with that. So our first step is, oops, my pen is not working very well. Our first step is we're going to solve one equation for either x or y. That's gonna give us something. So we're gonna be left with something that looks like either x equals something or y is equal to something. After that, we're going to substitute that expression into the other equation. And apparently I'm running out of good pens. So we're going to substitute that expression into the other equation. That means that whatever is left should only have a single variable. Once we've done that, we can solve, and then we're going to back substitute. Which means that we're going to take the answer that we got in this third step and we're going to substitute it back into one of our original equations. And frankly, I like to use it in these because it is fairly easy to do the calculations. Now, this is a lot of words, so let's show you an example. Let's show you what we can do. Say we've got something like this. Say I've got, and I'm going to actually give us one where everything is already solved on one of these equations. So here, let's do 2x minus 3y is equal to 12. And I'll do y is equal to 2x minus 8. With this, I need to go through and find my good pens. With this, I've already solved this second equation for y. So this is y is equal to this 2x minus 8. So what I'm going to do is I'm going to take this expression and I'm going to substitute it in for this y. So it's 2x minus 3y, but things that are equal are interchangeable. So this is going to be 2x minus 8 is equal to our 12. And then from here, we can go ahead and solve. So I've got 2x minus, I'm distributing through a -3, so it's going to be minus 6x plus 24 is equal to our 12. I'll combine my like terms, so I've got minus 4x plus 24 is equal to 12. I'm going to subtract 24 from both sides. So I've got negative 4x is equal to negative 12. And then I'm going to divide both sides by -4. So whenever we're solving, it's always simplify, add or subtract, divide. And now I've got my answer and I'm on the edge of this page. So I'm going to just do this here. This is going to be x is equal to 3. Well, now I can go ahead and back substitute. So this was the solve. This was substitute. And so here we solved for y. It was already done. Here we substituted. All of this right here is just solving. And then we are back substituting. We're going to take this answer and we're going to plug this into one of our original equations. And since I've got y is equal to 2x minus 8, this is already nice. This is already a nice setup to find our y. I'm just going to plug this x equals 3 into here. So I've got y is equal to 2 times 3 minus 8, or that's going to be y is equal to 6 minus 8, or y could be equal to negative 2. So my solution here is 3, negative 2. That's the solution to my system. Now, it's not always going to be this straightforward. Here, in this example, we already were given something that was solved for one of my variables. Well, it's not always going to be quite that straightforward. So let's do something, and I'm still going to be fairly friendly with this, but let's do another example. And in this one, how about we do something like x minus 3y is equal to negative 1, and I'll do 2x minus 3y is equal to 4. Now, I know this is a good setup for elimination, but we're doing substitution. And on this, we need to go ahead and solve for one of our variables first. So I look at this and I see that this top one, I've got a coefficient of 1 right here. So I'm going to solve this top equation for x. So I've got this x minus 3y is equal to negative 1. I'm going to solve this by, I'll just add 3y to both sides. So now I've got x is equal to 3y minus 1. So this, now we have solved this one for our x. And I have to substitute into this other equation. So I've got this 2, instead of x, we're putting in this expression, that 3y minus 1. 3y is equal to 4, because it's 2x minus 3y equals 4. We'll go ahead and distribute. So I've got 6y minus 2 minus our 3y is equal to 4. I always like to combine my like terms before I do any addition or subtraction. So I've got 6y minus 3y is going to be 3y minus my 2 is equal to 4. Now I'll add or subtract both sides. I'm going to add 2. So I've got 3y is equal to 6. And when I divide by 3, I've got y is equal to 2. Now I'm going to take this and I'm going to back substitute into one of these. And honestly, this is a good setup. So I've got x is equal to 3y minus 1. If y is equal to 2, then everything's already set up on one side. 3 times 2 is going to be 6. I've got x is equal to 6 minus 1, or x is equal to 5. So now my solution to this system is 5, 2. Now there's a couple things we should pay attention to, because not always, we've got a couple special examples that we need to be aware of, and those are things like when there's no solutions, or when there's an infinite set of solutions. So let's take a look at what that might look like. Say I've got a system that looks like, let's say I've got like y is equal to 2x minus 4. And then I'm going to do something like 4x minus 2y is equal to 8. And here we're going to see something interesting happen. I've already solved this top one for y. So I can just go ahead and directly substitute. I'm going to substitute this expression in for my y in this other equation. So I've got 4x minus 2 times, no, that's 2x minus 4 is equal to 8. And hey, look at this. I've got 4x minus 4x plus 8 is equal to 8. Well, I can, when I add these together, I've got 0 x's. So I've just got 8 equals 8. If we were to graph these, you'd notice that these are the exact same line. This right here is a true statement. All of the variables eliminated. We're left with a true statement. This is a dependent system. Or since this is true, we also, anytime we're left with a true statement, it basically indicates that we've got not just one solution, but a lot of solutions. In fact, we have an infinite set of solutions. If we had something where there were no solutions, well, let's say I've got something like, I'm going to do 5x minus 2y is equal to 4. And let's say we've got something like, let's say I've got y is equal to 5/2 x plus 1. Oh, this is ugly. We've got fractions. Fractions happen. It's okay. But we've already, I'm just demonstrating a point of what happens at sometimes. So let's see what happens when we substitute this expression in here. So I've got 5x minus 2. Instead of y, we're putting in this expression. Things that are equal are interchangeable. 5x plus 1 is equal to 4. Well, let's go ahead and distribute. 2 times 5/2 is going to be just 5. Well, negative just changes the sign. So we've got 5x, no, minus 5x. Then minus 2 is equal to 4. 5x minus 5x is 0. So I've got negative 2 equals 4. Well, again, all of the variables eliminated. But negative 2 does not equal 4. We went and broke math again. Dang it. Here we've got no solutions. These two lines would be parallel. This is no solutions, or this is also called an inconsistent system. Alrighty. Hopefully this gave you guys a little bit of clarity, and we will see you guys in the next video.